in binoculars and magnifying glasses, for instance. But how does a lens function? Well, the main purpose of the lens is to refract the light in some pattern. There are basically two patterns, convergence and divergence. But before studying these two patterns, we first need to understand how the light is refracted by a lens. Consider a convex lens and suppose a ray of light is incident onto it at an angle. This is the normal at the point where the light ray is incident. Now consider a point object here from where this ray is emerging. What will happen when it enters the lens? This ray is travelling from one medium to another at an angle, so after entering the lens, its speed will change, which will result in its bending. Will the speed inside the lens increase or decrease? And where will the light bend? Well, that will depend on the incident medium. Suppose this medium is air. So from this table, we can see that the refractive index of glass is much greater than air. This means that glass is optically denser than air. Hence, the speed of the ray of the light will decrease in glass, and because of that, it will bend towards the normal. Alright, so now what will happen when this refracted ray has reached the other spherical surface of the lens? From there, the ray will be refracted again as it enters another medium, which is air again. You see that this time it bent away from the normal. Can you tell me why? Air is optically rarer than glass, and hence after entering air, speed of the ray increases and it bends away from the normal. And this is how the light ray is refracted by a convex lens. Here only one ray is emerging from the point object. But in reality, there are many rays that emerge from this point object and not only one. All these after striking the lens will be refracted in the same way. Did you see something strange? Yes, all the rays meet at a common point. Or we can say that all the rays are focused or converged at a single point. And this is one of the patterns that we were talking about. Convex lens bends the light rays from a point object in such a way that after refraction, all these rays converge at a single point. And this is the point where the image of the point object is formed. If we were to place a screen here at this location, then the image will be formed on that screen. Since the convex lens converges all the light rays at a single point, we also call it converging lens. And what about a concave lens? How do they refract light rays? In the previous part of this lesson, we've seen why a convex lens is called a converging lens. Now let's discuss the concave lens in detail. It refracts the light in a similar way. A ray of light after entering the concave lens bends towards the normal, and when it again enters air, it bends away from the normal. Will the concave lens behave in the same way as the convex lens? Will the rays converge after refracting from a concave lens? If the rays from a point object are incident on a concave lens, then after refraction, they do not converge at a single point. These refracted rays diverge. It means they go away from each other. But wait, since they do not intersect at a common point, does that mean no image is formed? Well, the image is formed. If we were to extend all these rays backward, they all meet at this point. The virtual image is formed at this point. So this is a pattern by which concave lens refracts rays of light. It diverges all the light coming from a point. Hence, it's called a diverging lens. Now let's look at both the lenses side by side. So the convex lens converges all the light rays from a point object, and the concave lens diverges all the light rays from a point object. But usually our objects are big and not just a single point. So let's use an arrow to denote an object. We can take points on the arrow and find out the image for each point. Finally, we join all the image points together to get the complete image. This is a real and inverted image. This is the image formed for an object when a convex lens is used.